Number 46, write a balanced equation for each of the following nuclear reactions, and then we have letter D, which is when neon-19 decays into fluorine-19. Okay, so we're dealing with nuclear reactions, which means that we have to write this in nuclide notation. Now there's 3 separate zones that we have to write for one nuclide notation. I like to use them as the colored boxes, which is here. So for each atom or each element, we have to fill in these 3 boxes. Now in this case, they are saying that neon-19 is going to decay into the fluorine, which means that the neon-19 is going to be my starting material, which is my reactant, and the fluorine is going to be my product, because that's what I'm decaying into. So we have neon-19 is going to decay, let's bring out another one of these, into fluorine-19. Okay, so let's start writing out the notation, right? So neon is Ne, but you could always look on the periodic table to see where neon is, right? Capital N, lowercase e. And they told us that it's neon-19. Now they do have to tell us these numbers because the 19 stands for the mass number. Now the mass numbers can change for the same element or the atom because you could have different number of neutrons. And neon-19 in this case, 19, it's the mass number, it's the number of protons plus the neutrons. And the mass number is always the number that goes on the top. So the 19 goes up here. But now the question is, what's the number that goes here? Well, that is the atomic number. And atomic numbers never, ever, 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 ever change for a given element. So we could go on the periodic table to see what neon's atomic number always is. And it's always the beautiful whole number. It's not the decimal number because that's the average mass. But neon is a number 10. 10 total protons always, and if you subtract these 2 numbers, which is 19 minus 10, you get 9. That's the total number of neutrons. Now, let's do the same thing for fluorine-19. Fluorine is capital F. They're telling me that I have a 19, so that's the mass number for this fluorine, so 19 on the top. I go on the periodic table to see what the atomic number for fluorine is, and that's a 9. Okay, so now we have to write a balanced equation for each of these reactions. Now in this case, if we just wrote this out, right, almost there, because there has to be some type of balance to it. You could use this as an equal sign, right? So 19 equals 19, that's all fine and dandy, but 10 does not equal 9. We have to do something in order to balance out those atomic numbers. Now, there's 2 things here, right? We can either put a new nuclide over here, or we could put our nuclide on the product side, or the reactant side. It doesn't really matter here, but I guess, I don't know, which one do you want to do, right? I guess we can do, maybe we'll switch it up, right? Well, maybe we'll put this over here, and we'll add here. But there technically could be 2 answers here, depending on which route you go. But let's put the subatomic particle here. Now, we got to figure out what these numbers are, right? 19 yields 19. So I know that this has to be a 0 because 19 plus 0 equals 19. So we're all good. But now 10 plus what will get me a 9, right? If you need to, you could always put it into an algebraic expression. 10 plus what will equal 9. And then just subtract on over the 10. X equals a negative 1. But now the question is, who is this? Well, a 0 and a negative 1 is always an electron, which is the same thing as a beta particle. So whether you want to put an E for an electron or a B, you're good to go, right? Because electron and beta are the same thing. So this would be kind of like a capture, right? This would be an electron capture example. If you wanted to move this over here, you would see that this would have to be a positive one. 9 plus 1 gets you 10. And in this case, 0 and a plus 1 is not an electron, it's a positron. So this would be positron emission, but in this case, we'll keep it with the electrons, and then this would be classified as electron capture. So this is one of your balanced equations. You could put the positron one as you want as well, but we'll keep it here, and this is the final answer. So that's it. I hope this worked. Thank you so much for viewing the video. Subscribe to the channel if you haven't already. Like the video, it just gets the word out there. We're almost at 50,000 subscribers, which that's all you guys. Thank you so much for watching these videos, and we're so happy to read the comments about how, this channel is helping you out in your classes. We got physics and math videos on the channel with more subjects coming in the future. If you want to become a member to the channel and give a little bit more to the channel to help us out more, you obviously can. Not mandatory, obviously, but thank you for considering, and I'll talk to you in later lessons, okay? Have a great day, and keep studying hard. You got this. Bye-bye.